Hey guys, I hope you are having a great week so far. Happy Wednesday. We are doing 5.3, so here we go. And we have an awkward glare. Let me see what I can do about that. Okay, hold on. Okay, sorry guys, I had to turn off the light because we had a glare and it was not good. Okay, so we're 5.3, solving trigonometric equations not on the unit circle, okay? So on Monday, we did ones that were on the unit circle. Today, they are not. So same process, just a little bit different. Okay, and to understand how to solve these, what we want to first look at is a few examples where they are on the unit circle. So if you look at this one, cosine of a half, if you got your unit circle, and we looked at cosine a half, that's at 60 degrees. Okay, it is also at 300 degrees. So let's look at this. So if we looked at our unit circle, at 60 degrees we have 1/2, comma, square root 3 over 2. So cosine is 1/2. Okay, and mine's really blurry. Hold on. That's not very blurry. There we go. Okay. Now you guys can see that. Okay, and the other one was at 300 degrees. So we have the 60 degrees, and then we had 300 degrees. That was 1/2 and negative square root 3 over 2. We know all students take calculus, so cosine is going to be positive in quadrant 1 and quadrant 4. Okay, what do we notice about this angle right here? Well, this is also technically 60 degrees negative, but 60 degrees. So my two answers were in the two positive quadrants, and they had technically the same reference angle of 60 degrees. Okay, let's look at a half. Oh, so real quick, our answer would be 60 plus 360n and 300 plus 360n if we were finding all solutions. If it doesn't say in a specific quadrant, assume that it's all solutions, okay? Let's look at cosine of negative a half. So negative a half, cosine is all students take calculus. That will be in quadrant 2 and quadrant 3. Okay, so in those two quadrants we should have our answers. So if we look at our unit circle, it's at 120 degrees. Is negative 1/2. And in quadrant 4, it is 240 degrees. Okay. Oops. Okay, so 240 degrees. Okay, so that's also where negative 1/2 for cosine. What if we looked at this reference angle right here? So if this is at 120, what's my reference angle? That's 40 degrees. Okay, if we look at right here, what's my reference angle? Well, if this is at 240, to get back to 180, we'd have to go back. Wait, hold on. Sorry, that's 60 degrees. We struggle, I struggle. If we go back, I was like, that is not going to work. This one is also 60 degrees. So if you notice, these two reference angles are the same. Again, our answers would be 120 plus 360n, and what was that? 240 plus 360n. Sorry about that, 60 and 60. So if you notice, our reference angles for these two answers are the same. Okay, this concept of the same reference angles is huge today when we look at the unit circle, because that's going to help us find our two angles. If you notice, we've always had at least two angles in every solution. Okay, and we know that's going to happen because with the unit circle we have repeats. That's why when we did the inverse, if we were solving for an angle, we had to limit the domain and range to remain a function. Okay, these ones are not solving trigonometric function equations. These are just trigonometric equations. So you do have repeats. Okay, so let's look at our first one. So what we're going to do is we are going to solve the equation, all solutions, write your answer in the indicated as indicated. So these ones are all going to be in degrees, and we're going to round our answer to 2 decimal places. Okay, so for this first one, if we solve this, this would be 2 sine theta equals 1 divided by 2. So sine theta equals 1/2. Well, this one's a little cheat. This one's on our unit circle. If we look at where sine is 1/2, that is going to be at 30 degrees plus 360n. And if you notice, 30 degrees is my reference angle. My other position where sine is 1/2 is over here at 150 degrees. And if you notice, this reference angle is also 30 degrees. So that whole same reference angle, depending on where you're at, applies. So this is going to be 150 plus 360n. Okay, so those are nice and easy, but let's try one that's not on the unit circle. So we'd get 2 sine theta equals 3 divided by 2 sine theta equals 3/2. So normally we'd solve this, we'd say theta equals sine inverse of 3/2. And again, remember, because of that domain and range restriction, this is only going to give us one answer. And some of you probably have already noticed this, but if not, this will be a surprise for you. So I made sure I'm in degrees. Second, inverse sine of 3/2. Any guesses what will happen? If you guessed error, you're absolutely correct. Why does this not work? What's wrong with this? Well, if you remember, sine theta is opposite over hypotenuse. My opposite is 3, my hypotenuse is 2. This ratio is not possible. So this is no solution, or not possible. Okay? Sneaky, sneaky. So if you're getting a domain error like this, check to make sure the ratio makes sense. This usually only happens in, actually this only happens in sine and cosine. Okay? So you're thinking, oh my goodness, there's none that we've actually done yet. Here we go. This one will work. So 5 sine theta equals 1, because we added the 1 over. Sine theta equals 1/5, opposite over hypotenuse. This will work. If you look at your unit circle, there is no 1/5 on our unit circle. So in order to solve this, we get theta equals sine inverse of 1/5. Okay, so second sine 1/5. Okay, so theta equals 11.54 degrees. So let's look at this. We get 11.54 degrees. This is where, I don't know what cosine is, but sine is 1/5. Okay, this is a positive 1/5. So all students take calculus. So my other position for a positive is over here. And this right here has to be 11.54. So how do I find this angle right here? Okay, what could you do to find that angle? Well, this angle, okay, if you notice, this is just short of 180 degrees. It's actually 11.54 degrees short of 180. So we're going to go 180 degrees minus 11.54 degrees, and that should give us 180 minus 11.54, 100, let me see that, yeah, 168.46 degrees. So if you notice, here's my two angles. So it's going to be 11.54 degrees plus 360n. Okay, that will get you this one over and over and over in both directions, positive and negative, because n could be any integer, positive or negative. And then my other one is 168.46 plus 360 degrees n. Those are my two answers. Okay, I'm going to do one more video, so make sure you watch it.